In this series of lectures, we're going to be looking at methods for integrating rational functions. You remember a rational function is essentially it's just a fraction, but instead of numbers, the numerator and denominator are going to be polynomials. Now, there's a number of different ways we can approach this kind of problem, but the biggest one is going to be something that's called partial fractions decomposition. Now, you may have seen this already, this method, in a pre-calc class or maybe a second year high school algebra class. If you have, that's great. If you remember the method, you're welcome to skip ahead to the third lecture after this one. Um, that's when we're going to kind of pick back up with calculus concepts. And I talked for a little bit about when you would want to use this method to do calculus problems and when you'd maybe want to try something else. All right. But if you haven't seen it before, or if you have, you just want to go over the method again. That's what we're going to do in this lecture and the two that come after it. So the goal behind this is to take a rational expression like this one and to split it up into the sum of smaller rational functions. And by smaller, I mean ones where the exponents are smaller. Right? For example, this one here can be rewritten as this. And you're welcome to check me out on this one, right? Try adding those two rational expressions together, and you should end up back with the one we started with here. And remember, the goal here is to be able to integrate these things. And integrating this one is a mystery. We're integrating these two. We do them separately, right? And those are just logarithms, right? It's going to be the sum of two logarithms. Right, so that's going to be our goal here. So we're going to look at four different scenarios. We're going to look at a situation where the denominator is made up of purely linear factors. We're going to look at a situation where there are purely linear factors, but one of them, at least one of them, is repeated. We're going to look at a situation where one of the factors, one or more of the factors, is quadratic, and then again we'll look at a situation where the quadratic factors are where there's a repeated quadratic factor. Now, you can go further than this. You can take this to cubic factors, quartic factors, whatever, and you'll see as we get further into this that you can apply the method that we're going to use here and extend it in a very natural way to deal with those higher degree factors. We're really not going to go there in this class. These are really only the four cases we're going to look at. You may have heard me say this before in other lectures. When I'm teaching calculus, my goal is to see if students can do calculus problems. It's not to see if they can do some really messy algebra and pre-calculus questions. And when we start getting up into cubic factors and higher, that's really what this is turning into. And to me, it's distracting from the calculus that we really are supposed to be focused on here. So these are the four cases that I'm going to talk about, and the problems that you're going to see me do, we won't take this method any further. Okay, so in the next lecture, we're going to jump in and we're going to look at the first two cases where we're looking at a rational expression where the denominator can be factored into linear factors and possibly repeated linear factors.